Hello, everyone. Happy Sunday. I wanted to check in and talk about what we're going to be doing this week. Please excuse the mess behind me. So first of all, I read through your forum posts for last week, and they were really thoughtful. I thought you guys were really on the right track. So thank you for taking the time to do that. It seems like you guys have a good grasp of what's important when looking at a survey research design. So I was very pleased with that. Also, once again, don't worry about the quiz grades. It graded all the short answers as incorrect, but I went through and everybody seems to definitely understand their research design as well. So please, those are just to mark participation and let me see where you're at, so don't worry about the grades there. What we're moving on with this week is looking at making sense of data. So I just wanted to start with a little example. In the beginning of the semester, we read an article about the radical right. And as we were reading that article, something stood out to me where it said, 65% of participants agreed with or supported this hypothetical party. And you guys might remember then we had to turn to the footnotes and we had to look at the question, and we had an interesting conversation about why we thought that was. But again, the article was about supporting the radical right. So if we think about that language and something being radical, being maybe fringe, outside the norm, it really stood out to me where they said 65% of participants agreed with that. And that number, of course, that percentage, that 65%, is a descriptive statistic. It tells us it's a summary of the data. So before we even jump into the fancy things like regression and our betas and our statistical significance, I just want to use that example to point out that it's really important to first begin by describing our data in meaningful ways, especially if we want our research to be accessible to a broader audience. Just framing what our data is telling us in language that most people can understand is very important. So before we jump into more advanced statistics, we have to begin with the basics. So that's what we're going to be working on this week in terms of looking at other data and also looking at your own data. We're going to talk about setting up your data sets and beginning to calculate some simple descriptive statistics. So again, like probably many of you, I'm not a math person. I've taken a lot of statistics in my life, but I still would not consider myself a math person. So I just want you to jump into this with a good attitude. We're going to keep it as simple as possible. I want you to be able to do just what you need to do to successfully communicate about your data. So just bear with me this week, and we're going to take it simple. We're going to take it step by step. So what I want you to do this week is begin by reading chapter 11 in your textbooks. I'm going to talk a little bit and go through some of the highlights of chapter 11 in this video right now. And then I want you to take a look at the assignment that I posted on our OnCourse page. And it's going to walk through an example to calculate descriptive statistics using a data set that's on our OnCourse page. And then I'm going to check in with you guys on Wednesday. I'm going to go live on Wednesday. I'll answer any questions you have about that assignment, and then I'll move on to teaching you how to calculate standard deviation and variance. And then I'll post another short assignment that will be due at the end of the week. So anyway, sorry, moving on from there. So anyway, start with your textbook, watch this video. And then if you're still having trouble, I also put 2 other short videos on our OnCourse page, one on calculating the measures of central tendency and one about creating a frequency distribution. So those are the two main things that I ask you to do for the part 1 of this week's assignment. So first of all, I realized that in my, the textbook that I have here with me at home, I have the 7th edition of the textbook. I know many of you might have a higher edition. So the material should be very similar, but I apologize if what I'm showing you is slightly different, but I think it should still work. So the first thing on one of the first couple pages in my my textbook is an example of a data matrix. So hopefully you find a page in your textbook that looks similar to this. So again, this is an example of the type of data matrix that I'm asking you to set up for your own data in assignment 2. Also, in addition to this example, I've put other examples on our on-course page, an example that used survey research, and another example that used the 50 states as the unit of analysis. And then third, the example that we're going to be using for this week's assignment is the 36 country data set. So again, when you're setting up your data set, your first column is always going to be your unit of analysis. So this example that I have today, the unit of analysis is countries. Something else that's important to be aware of is with the individual variables, of course, each individual variable becomes a column, and then each number is the observation for that particular country. So you read it across as each observation and as each variable. So when you're looking broadly at a data set, there's a few things you want to keep in mind. Of course, first, what's going to be really important is what is your N? What is your number of observations? So obviously, when we're looking at that 36 country data set, our number of observations is 36, the 36 countries. If you're doing your survey, of course, your N is your number of respondents. So we always want to be clear what our N is when we have a data set. Something else to be keeping in mind as we walk through the descriptive statistics is it's important to be aware of the level of measurement of your variables. So I told you guys you'd be annoyed with this because this never goes away. But again, level of measurement is important. For each independent variable, is it ratio level of measurement? Is it ordinal? Is it nominal? And the reason that's important is because the type of statistics that you calculate may be more or less meaningful depending on the level of measurement. So when I'm looking at my example from chapter 11, I'm seeing there's a Gini index, which sounds like it would be an ordinal level of measurement. Then I have things like percentage of GDP, age, population in thousands, definitely ratio level of measurement. And then I have the final variable, political culture, which is either Anglo-American or European. So that's definitely categorical. That's a nominal level of measurement. So I have a little bit of everything going on in this data set. So I just like to kind of check that out first. So of course, when you're looking at a data set and you're staring at a bunch of numbers, there's not really much you can just verbally conclude from that just by looking. And that's why descriptive statistics become so important. How can we describe our data in meaningful ways? How can we turn those just raw numbers, is what we call them, into some descriptive statistics that allows others to be able to conclude something meaningful from our data set? And that's where we begin with descriptive statistics. So the first thing discussed in your textbook is frequency distributions, proportions, and percentages. And there's a table. This is the 11.2 in my textbook. It's just what I'm showing you. Again, yours might be slightly different. But what I want you to take a good look at is the table that shows an empirical frequency distribution. And what you'll see is that the first column in your frequency distribution is going to be the different categories for one of your variables. So in this particular example I'm looking at, the different categories are strongly agree, agree, uncertain, disagree, disagree strongly. And the question was, this is from a survey design, do you agree, strongly agree, uncertain, disagree, or disagree strongly with that the rich and powerful people in this country have too much influence on politics? So again, the variable was a survey question, and they were given this option of an ordinal scale in terms of their answers. So again, an ordinal scale would be a good type of variable in which to calculate a frequency distribution. I might also think of examples in which you might have a nominal level variable, like you wanted to know how many of your participants were from each region of the country. And you could do a frequency distribution with that. Ratio level variables, usually it might be less useful to do a frequency distribution because there's so many different categories. If I was thinking about doing a frequency distribution for instance, looking back at the data set aged population in thousands, a first quick look would show me that all of those numbers appear to be different. So if I did want to do a frequency distribution there, I would have to put them basically into categories. How many of the countries fall within 0 to 500, 500 to 1,000, something like that. So anyway, just something to think about when you're looking at your own data set for assignment 2 and you're thinking about calculating a frequency distribution. You're probably going to want to choose a variable that is nominal or ordinal level of measurement. And if it's ratio, you might have to summarize the data into categories first. So to me, your book uses some symbols. It sometimes makes things seem a little more complicated than it really is. Really, when we're talking about frequency, all we're talking about is how many of the observations fall into a particular category. So reading the table from my version of the textbook, I see that 333 people strongly agree. All I read that is that's the number of observations. So for yours, it might be the number of countries that are in the Middle East, something like that. It's just the number of observations. So it's simply organizing your data so that you can count how many of your observations fall within a particular category. And that is the frequency. The proportion then is just the frequency. It's that number that falls into that category divided by the total number of observations. So again, that's why it's important to always know your N. Looking at the frequency distribution table in my textbook, the total is 995. So in order to get the proportion that strongly agree, I would just divide 333 by 995. So thinking about your assignment for class, the N again is 36 countries. So if you're calculating a proportion, it's the number, the frequency, divided by 36, because that's your number of observations there. So the type of frequency table that I'm asking you to do is it shows the frequency, that's just the count in each category, the proportion, which is the frequency divided by the total number of observations, the relative frequency percentage, which really is just turning the proportion into a percentage, so moving it over to data points. In my example in the textbook, they they added a different decimal, so it's a little more precise, which made it a little confusing. But really, that's just turning your proportion into a percentage. And then the last category is the cumulative percentage. And what they're doing there is just adding the numbers from the relative frequency. So if I see, in my example, it says, 90.9 here. I'll show you with uncertain, 90.9. What that's just telling me is that, 90.9 people range either were uncertain, agree, or strongly agree. It's just adding up from these columns. So the last number in your cumulative frequency percentage is always going to be 100%. So it's this plus this got us this plus this gets us to our 90.9. So hopefully that makes sense after you take a look at it. So really, it's not that complicated. Another thing, of course, that they make important point about is that you have to be sensitive to missing data when calculating these statistics. So if you don't have an observation, if you don't have that variable for each of your observations, then that's going to affect your N. If you only have that data point for, say, 30 out of your 36 countries, then of course you would have to be dividing by 30 as well, because that's going to really affect the accuracy. Okay, so the second thing to think about beyond frequency distributions, okay, so those are of course important because they let you know how many falls within each category. So we could show that as just a table. We could easily turn that into a bar graph or a histograph showing that. And if you want an example of what that looks like, they show an example in the video that I posted for class. But the other thing I wanted to just talk briefly about right now is measures of central tendency. So one thing we want to know, a way to describe our data is, what does the middle look like? So measures of central tendency are different ways to think about, quite simply, kind of what does the middle of our data look like? What's the average? What's the mode? What's the median? And then by comparing the three of those, it might tell us even more about our data. So first of all, a term that I want to begin with is the range. What is your data range? When I ask that, I'm basically asking, what is your lowest observation and your highest observation? Again, something like a range is going to be relevant when we're talking about definitely ratio level data. What was the country with what was the lowest GDP? What was the highest GDP? That would be our GDP range. It might also be a bit relevant for ordinal level data. If we have a scale, maybe something like the Gini index in this example, what was the lowest? What was the highest? Of course, with categorical or nominal level data, there's not going to be that lowest, highest to speak about. So a range is not going to be very significant. And the same is true then for our other measures of central tendency, like a median or a mode as well. So if something can't be rank ordered, it doesn't really make sense to talk about measures of central tendency. So again, keep that in mind. This is best for ratio and interval, ratio, interval, ordinal level data, not our nominal categorical data. So our mean is just another word for our average. What is the average? In order to calculate our average, we just add all the different observations and then divide by the total number of observations. So for instance, with my data chart, if I wanted to do the mean number of union density, I'm simply going to just add the entire column of data, and then I'm going to divide by my number of observations, which is my 21 developed democracies. So simply add these together and divide by 21 gives me my mean. So you can think about easily how you would do that for your own data. Of course, with our 36 country data, you're adding and then dividing by that number of observations. Something else we might see is a trimmed mean. In a trimmed mean, you typically drop the highest and lowest observation, and then you divide by that new n. So if I was doing that with the 21 countries, I would drop whichever country had the highest, what did I say, the highest union density, the lowest union density. And then because I dropped those, my number of observations is not 21, it's 19. So I would divide by 19 instead. Sometimes if we have in our data what we call outliers, that if we have, one that's really out there, so our data is kind of clustered here, like everybody was getting A's and B's on the test, and then somebody got like a 12%. That's an outlier, right? So if you included that outlier in the data set, it would make it look like our average was really a lot low. Our average is showing that things are a lot lower than kind of what our data in reality is showing, that everyone was kind of clumped in getting A's and B's. So that's why sometimes we might want to calculate a trimmed mean and then maybe compare it back to our mean, and that could let us also know then if there are outliers. If our trimmed mean is very similar to our actual mean, then we know that there aren't severe outliers in our data as well. So the median observation is the observation that just falls in the middle. So if you organized one of your variables, one of your ratio or ordinal level variables from highest to lowest, you just simply see what falls right in the middle. Of course, sometimes it's going to be that two are in the middle. So in that case, what you're going to do is add them together and just divide by 2. And then of course, if it's an odd number, then you don't have to add and divide, because there will simply be one right in the middle. And then finally, the third measure of central tendency is the mode. And that actually is related to our frequency. It's just it's the number that shows up the most in the data set. So this could be something that's particularly useful in ordinal level data, that, what did respondents say the most on the scale? A lot of times for ratio level, the mode might not be the most intuitive level of measurement to be working with. So if you are seeing, if you're then calculating your mean, your average, your median, looking for the middle, your mode, whatever observation showed up the most, if there's a lot of similarity between your mean, median, mode, that's going to be an indicator that there's like a normal distribution in your data set. And that's that bell curve that we've seen before. And that will come up again, but we'll just leave it right there for now. So what I would like you to do from here, again, read the textbook chapter on its own. Again, don't get hung up in the formulas unless that's your thing. You can always come back after you read it, watch this video again. Watch the other videos that I posted on our OnCourse page, and then please just take a look at and begin working on the assignment for this week. So again, what you're going to be wanting to use for that data set is the 36 country data set, which is posted on our OnCourse page right above this week's lessons. There's also a code book for the data set that you might need to look at as well. And then I'm going to log in again live Wednesday at 1. I can take any questions you have about the frequency distribution, the measures of central tendency. And then what I'm going to go over with you guys live is then moving on to calculating variance and standard deviation as well. So thank you for listening. Contact me this week with any questions and begin working on that assignment. Thank you.